A developer deploys an EC2 instance, the app launches fine, but nobody can reach it from the internet. No error, no obvious reason, just silence. 9 times out of 10, the problem isn't the app, it's the network it's sitting inside. An AWS VPC, Virtual Private Cloud, is your own isolated network inside Amazon's cloud infrastructure. You define it, you control it, and nothing gets in or out unless you explicitly allow it. Think of it like this. AWS is a massive office building with thousands of tenants. Your VPC is your company's floor. You decide the layout, which doors exist, who has keys, and whether the elevator even stops there. Other tenants can't wander in. You're sharing the building, but the space is entirely yours. Every resource you launch on AWS, EC2 instances, databases, load balancers, lives inside a VPC. You either create one deliberately or AWS drops it into a default VPC and you inherit whatever configuration that comes with. That matters because the default VPC is wide open by design. It's fine for testing, it's a liability in production. Teams get burned when they move fast early on and don't think about network isolation. A database that should only be reachable by your application server ends up accessible from anywhere. Not because someone made a dramatic mistake, but because the VPC was never designed with intent. Understanding VPC networking is what separates infrastructure that holds together from infrastructure that quietly exposes things it shouldn't. When you create a VPC, you assign it a CIDR block. That's just a range of private IP addresses, something like 10.0.0.0 tier 16, which gives you 65,536 addresses to work with inside that network. Inside the VPC, you carve out subnets. A subnet is a subdivision of that address range tied to a specific availability zone. You might create 10.1.024 as a public subnet and 10.0.2.024 as a private subnet. The word public or private isn't a setting. It's a result of how the subnet is configured. Here's what makes a subnet public. It's associated with a route table that has a route pointing to an internet gateway. An internet gateway is the component that connects your VPC to the public internet. Without one, traffic has nowhere to go. Route tables are exactly what they sound like. A set of rules that say traffic headed to this destination should go through this path. Every subnet is associated with a route table. If a subnet's route table doesn't have a 0.0 route pointing to an internet gateway, it's private. Traffic can't leave to the internet and the internet can't reach in. There's also the network ACL, Network Access Control List, which operates at the subnet boundary, and security groups, which operate at the instance level. ACLs are stateless, meaning they evaluate inbound and outbound rules independently. Security groups are stateful. If you allow a request in, the response is automatically allowed out. And if this is the kind of deep infrastructure thinking you want to build, Stack Future covers one concept like this every day. These layers work together. Traffic hits the internet gateway, gets evaluated against the route table, crosses the subnet boundary where the ACL checks it, and finally reaches the instance where the security group makes the last call. You launch an RDS database, Amazon's Managed Relational Database service, and your application can't connect to it. The connection just times out. You check the database, it's running. You check your application server, it's running. The error you're getting is simply connection timed out on port 5432. Here's what's actually happening. The database was launched in a public subnet, but its security group only allows inbound traffic on port 5432 from a specific source. That source is set to 0.0 everywhere. So that's not the problem. The real issue is the route table on the application server's subnet has no route back to the database's subnet. They're in the same VPC but isolated by routing rules that were never configured to allow traffic between them. The fix: update the route table, or more correctly in this case, verify the security group on the RDS instance is allowing traffic from the application server's specific CIDR block or security group ID, not just any IP. That's the correct pattern. That's what intentional VPC design looks like. A VPC is your private network in AWS, and every routing decision, every subnet boundary, every security group rule is you defining exactly how traffic moves through it. Nothing is automatic. Everything is a choice. Next up, CI/CD pipelines. What actually happens between a developer pushing code and that code running in production. It's a more interesting sequence than most people expect. If this one made something click, a like helps more people find it.